record the session. So here, if you want to solve an equation by using the maple, as I told you, assume that, for example, we want to solve an equation, something like this, for example, an equation with 2x double dot, for example, plus 3 times by x dot plus 40 times by x is equal to, for example, the non-homogeneous term is 100. This term can be changed, okay, but for now only we consider this term 100 Newton, and I will explain that if it will change, what should you do. And now we want to solve this equation by using the numerical methods. In the numerical methods, the first step, you need to convert the ODE. Here we deal with ODE from order 2. If your ODE was from order n, you need to convert it into n ODEs from order 1. And here, when we have a system of ODE with order 2, so we can extract two equations with order 1. We need two parameters. The first parameter is x1, and we consider x1 which is equal to x, and x2 which is equal to, in fact, x1 dot, or it's equal to x dot, you know. So you can substitute into this equation. If we call it equation 1, in equation 1 you can substitute in terms of x1 and x2. X double dot, in fact, is x1 double dot, or it's equal to x2 dot. So we will have 2 times by x2 dot plus 3 times by x dot. This term is equal to x2, so it will be 3 times by x2, and plus 40 times by x, which x is equal to x1 from here. So 40 times by x1, it's equal to 100. So from here, we can extract that from this equation, equation 2, you can obtain that x2 dot is equal to 100 minus 3 times by x2 minus 40 times by x1 divided by 2. Okay, so this is x2 dot, and x1 dot is here. x1 dot is equal to x2. So you can see the first equation, equation 1, was an ODE from order 2 instead of equation 1. Now we have two equations, equation 3 and equation 4, which most of them are from order 1. As you can see here, we have the derivative with respect to time with order 1, x1 dot and x2 dot. So this is the first step. Now we can form the vector f, which vector f, in fact, is x1 dot, yes, and x2 dot. And it's equal to x1 dot is equal to x2, and x2 dot is equal to this term, the equation 3, and it's equal to 100, this term. I do not write here. So this is the f. And also we have one initial condition, x naught. Assume that, for example, the initial condition is 0. So x naught is 0 and 0. Okay, so this is the total procedure. Now we need to use an algorithm to write a code. Let me here. Now we do the first step. Now we want to use this algorithm to write a mathematical code to solve this equation. So we extract this vector x dot, and also we have the initial condition and t naught, which t naught, in fact, is the start point. Assume that you start from 0. We want to obtain, for example, we want to obtain the response. We want to solve this equation and obtain the response for t between, for example, 0 and 20 seconds. It's up to you according to your problem description. We want to obtain the response, the x, between 0 and 20. So t naught is 0. In this case, t naught is 0. We have the x naught. For this case, we only have x1 naught and x2 naught because this is an ODE from order 2. So only we have these two terms. We don't have n x at t is equal to 0, only 2x. And also we have x dot, or the vector of f. Okay, so clear so far? Is it clear so far?
Yes, sir.
Okay, the next step, we want to use this algorithm. I prepared this today for you, and I will upload it on Moodle. You can use this algorithm to write your code. Of course, you can use any other software by using this algorithm. You can use Mathematica, you can use MATLAB, or any other software that you want to use. Of course, you need to use a for loop or a loop in your program to write this code. Today, I will show you how to use Maple to write this code. It's very simple. I will show you. But this algorithm for all of the programming can be used. So the first step after forming this x dot and x naught is forming the k1. K1 is the parameter in your, because we are using the range quota of order 4, the fourth order range quota, so we need to calculate K1, K2, K3, and K4. K1 is equal to h times by f times f at x naught and t naught. It means that here in vector f, you need to substitute x naught and t naught. Let's back to here. This is the vector f. As you can see, the vector f is x1 dot and x2 dot. x1 dot is equal to x2. So when you want to calculate f for x naught, it means that for x2 you should substitute 0, and for x1 you should substitute 0, because these are the components for x naught. This is the x1 and this term is x2. So in f, if you substitute, instead of x1 you substitute 0, and instead of x2 substitute 0, you can calculate the f for x naught. Okay, so when you want to calculate f for any vector like x, you need to have this vector x. This vector x, the first component is x1 and the second component is x2, and then you can substitute for x1 dot, you need to substitute x2. It means that the first component in vector f is the second component in vector x, and the second component in vector f can be calculated from equation 3. I mean, you should substitute for x2 and x1 and calculate the equation. By using the equation 3, you can calculate the second component for vector f. So by using this equation, you can calculate k1, and the next step, you can substitute and find x1, which x1 is your new vector x that you needed. Instead of x naught, instead of this vector, you need this x1 to substitute and find k2. So x1 is equal to x naught plus half of k1. K1 is calculated in this step. In the next step, we use k1 to calculate x1, and t half, or t sub 0.5, is equal to t naught plus half times by h. Of course, in this equation, because we don't have time in the non-homogeneous term, so practically we don't need this term, but this is the total procedure that you may need it for other equations. So x1 can be calculated by using the k1, and the next step, we need to calculate k2. As you can see, k2 is similar to k1, only instead of x naught, you need to substitute x1. So here in, let me move to here. Here in this equation, again, we have, so vector f, which is x1 x1 dot and x2 dot. Okay, and x1 dot calculated from equation 4 here, and x2 dot calculated from equation 3. So it will be obtained from equation 4 and from equation 3. So you only need this time to substitute for equation 4. This time instead of x naught, you should substitute x1 to calculate f, and then you can substitute and find the value for k2. Again, after k2, you can use the value for k2 to calculate x2, and then by using the x2, you can calculate k3, and then find x3 and k4, and finally you can find x4. The next step, you should repeat this procedure, but this time you need to substitute for x naught, because x4, in fact, here, this x4, in fact, is your response at t is equal to h. Okay, I mean, for example, if we assume that this is the response x and this is the time, we start from here, you know, we start from here because x at t is equal to 0, and x4, if we assume that this is the h, x4 in fact is the response at t is equal to h. So if you find x4, now you calculated the response at t is equal to h, and now you want to calculate the response at t is equal to 2 times by h. So at this step, you need to use the response at t is equal to h as your x naught, as your initial condition, to calculate the response at t is equal to 2h. So again, you need to do the same procedure. Here, repeat these steps from this time from h to find the response at t is equal to 2h. So for this purpose, you need to substitute. Instead of x naught, you should substitute x4, and instead of t naught, you should substitute t1, which t1 in fact is equal to h. And then you can go here and start again and substitute and find f, k, calculate again k1, x1, k2, x2 to calculate x4. This time x4 in fact is equal to, again, the response at t is equal to 2h. And then you should substitute x naught is equal to x4. This time t naught is equal to t1, which t1 is equal to 2 times by h. Okay, so this procedure will be repeated until you achieve to time is equal to 20. So if you want to write a code in Maple, you should only use a for loop to write this code, and then you can repeat, because if you want to calculate this, for example, for 20 seconds, and if you assume that, for example, your h is equal to, for example, 0.05 seconds, you need to repeat this steps 400 times, and it's not logic. Okay, so it's not possible to do it manually or by handwriting, so you need to use a software to write a mathematical code, and for this purpose you need to use a for loop. Clear so far? I want to use the Maple to write this for loop. If it's clear, I can move to the Maple. Okay, so let's move to the Maple. This is the environment of Maple. As I told you, you can easily install it, and then you can open this software. As I told you, for this one, you need to go to Windows, Program Files x86, Maple 2015. This is the direction, and at the file bin.win, you can open this file, cw maple. Okay, of course, we have another form for Maple, another environment, but I use this one because I prefer this one. So in this environment, I start with a restart, usually. After each comment in Maple, you should use semicolon, as you can see. And to define each parameter, you need to use a column and equal, okay? For example, in this case, I want to define H is, for example, as I told you, I want to find the response for this equation. Let me here. For this equation, equation 1 for t between 0 and 20. So in this case, I want to divide this interval into 400, for example, intervals. So the h is equal to 20 divided by 400. So h is equal to, as I told you, to define the equal in Maple, you need to use this sign, column, and after column we have equal. So it will be it means equal. H is equal to 20 divided by 400. Okay, after I should use semicolon or column. If you use column, the results will not be shown, but if you use semicolon, you can see your parameters. So we have H. The next thing that we needed is x naught, the vector of x naught. To define a vector, I use vector with two components, 0 and 0. So by using this command, I can define the initial vector. As you can see in Maple, it's very easy, and this is the reason that I use this software, because it's really easy. Everything that you talk, everything that you say, you need to write it here, and it will be the Maple commands. Okay, so vector with two components, and with the components are 0 and 0. So easily I defined the vector with two components. And also I need another matrix, because I want to save the response in each. Here in this loop, when I finish this procedure, I need to save this x4, and also I need to save this t, the time, because if I do not save them, at the end of the procedure, I only will find the response at t is equal to, for example, 20. Okay, at each step I need to save the response. So for this purpose, I define this matrix R, the response, the matrix, and because I need to save 400 steps, so I assume that it has 401, because we will have one extra step, 1 and 2 columns. So this is a matrix with 401 row and 2 columns. Each, for example, here, let me show you. This is the matrix R that I'm defining here. It has 401 row and 2 columns. In each row, we have 2 components. The first component, I want to save the time, and the second component, I want to save the response x. As you know, this x is equal to x1. So I need, at the end of each loop, I need to save the x1 and time. So let's back to the program. So this is the matrix R. Let us start. If I need any other parameters, again we can back and define it. So I use the for loop in Maple. For this purpose, I use exactly this method. First you should write for space. We need to define an index. I use I, which start from 1 to 400, and during this procedure the Maple should do, when you want to continue this for, do not enter, because if you enter, you will face with this warning, because this 4 is an open loop, so I need to continue. For this purpose, you should like, use the shift and enter. By using the shift and enter, you can continue to write. So for I from 1 to 400, first step, I need to define K1. Let's show you. And also in Maple, anytime when you use hashtag, the Maple will ignore this line. Okay, so anytime when you want to add some explanation in your code, you can use the hashtag. So the vector f was equal to a vector which the first component, let's back to the note, the vector f, the first component in this vector is equation 4. Yes, it's x2. And the second component is 100 minus 3 times by x2 minus 40 times by x1 divided by 2. This is the vector f. Okay, so we need to use this vector to calculate k. So again, back to this procedure. So I need to calculate K1, the first step in the Maple. So in the first step, I define K1 is equal to H times by, this H is defined here. So it will be H times by the vector F. So the vector F is a vector with two components. The first component is, as you can see, is x2, which x2 is in fact the second component of your initial vector x naught. So I substitute x naught 2. Okay, because x naught 2 here, I will show you x naught 1 is 0 and x naught 2, it's the second component of x naught, which is again 0. Okay, so this is the command that we use to define x1 and x2. And the second component for vector f is this term. I will copy exactly here, but instead of x2, I should substitute x naught, second component, and instead of x1, we have x naught, the first component. So before using the for loop, first let's check the results. Here I use I is equal to 1. So here you can see I define the vector K1. This is the vector K1. The first component is 0. The second component is 50 divided by 120 divided by 20, which this 1 divided by 20 in fact is your H. So this is the K1. The next step, we need to calculate X1. So close it. X1 is equal to x naught. Of course, when we want to calculate a vector or a matrix form, we should use the command eval_m Maple, because we want to find the summation of two vectors. So I use this eval_m x naught plus half times by K1. This is the x1, and now you can see this is the vector x1. The first component is 0. The second component is 5 divided by 4. If you remember here, K1, the first component is 0. The second component is 5 divided by 2. We have another half here. So x1 is 5 divided by 4. So this is the x1. And now we need to use x1 to calculate K2. This is a K2, which is exactly the same as K1, but this time instead of x naught, I substitute x1. only instead of the vector x0, I substitute x1. This time, if we open it, you can see this is k2. You can see that k2 is not, the first component of k2 is not 0 anymore. So we continue. Now we need to calculate x2. Yeah, x2 is equal to x0 plus, of course, like here we should use eval m because this is a vector calculation, it's not a variable. So x2 is equal to x0 plus half, only instead of k1 we should substitute k2. So this is the x2, and now we need to calculate k3. Again, you can copy from the previous part, but this time k3, only instead of x1 we have x2. So we only substitute instead of x1 x2, and you can see this is your k3. We are calculating step by step. So the next step, we need to calculate x3, which x3 is equal to, again, I use this command, x0 plus k3. To calculate x3, we don't have half, only we have x0 plus k3. This is the x3. Let me show you. This is the x3, as you can see. And now we can find k4, which is the last parameter in your formula. So k4 is equal to h times by the vector f, but this time instead of x2 we have x3. Okay, so this is the vector k4, and now we need to calculate x4, which x4 again will use this command, x0 plus, this time it's equal to 1 divided by 6 multiplied by k1 plus 2 divided by 6 multiplied by k2 plus 2 divided by 6 multiplied by k3, and finally 1 divided by 6 times by k divided by 4. As you can see, this is x4. In fact, this is the response at t is equal to h, this part, the first component. So we calculate x4. Now we need to save the x4, because the next step we need to substitute, instead of x0 we need to substitute x4, and again do the same procedure. But here, before that, we should save these results. For this purpose, as I told you, the first column in the matrix R is the time. So here I substitute R, the first column. Of course, here the first column is substitute. The first column is here. We should substitute here. Let me substitute here. The first column R1 and 1 is x0 1 and also of course it should be 0, because the initial condition is 0 and the time is 0, start from 0, so I substitute both of them 0. So the first row and second column is 0. So by using the same procedure, I need to substitute for the next step, the second row. Here I use I plus 1, because in each step, when we repeat this loop, this I will be increased. So I will increase by 1. So the next step it substitute in save in the third row. The next step it will save in the fourth row, and so on. Okay, so here I use this command I plus 1. It means, for example, here in the first loop, when I is equal to 1, it will save in the second uh, row. Here in the first row, I save the initial condition 0 and 0. The time is 0 and the response is 0. But in the second row, I need to save for the second row, which is I plus 1 and 1. So I substitute I times by h. Here, this means, because in the first step, again, when, for example, when I is equal to 1, here the second row is the response at t is equal to h. For the third row is t is equal to 2h, and so on. So I use this command. And finally, I need to save the response for the second column, and it's equal to x4 1. As I told you, x4 is a vector which is equal to x naught. Here, if we back to this solution, the vector x naught was equal to, here was equal to x naught and v naught. So the first component in the vector x naught, which x4 is similar to x naught, the uppercase x naught, is the first component is your response. Okay, so we need to save this component. So here I save it in the matrix R, and it's equal to x4 1. So the next step, we need to substitute x naught is equal to x4. And if you had time in your equation, here in this step, you need to substitute t naught is equal to, for example, I times by h. Of course, in this specific case, we don't have time, so we don't need to write it. And finally, I think it's almost finished. Oh, at the end of your loop, you should use this command od. It means that your loop command is closed. So here, let's close this and repeat this vector. I hope it works. The left hand side in assignment, x naught we define x naught is equal to this vector. So the problem is not from here. Let's open it again. Plus 1. Find where is the problem. x4 is calculated, so the problem is in this command. I don't know why. This matrix is defined here. Our matrix is defined. Oh, sorry. Here instead of this bracket, I should use this bracket. I